So hello, everyone, and welcome to another wonderful lecture. This is lecture number 6, Math 140 Science. And last time we started chapter 3, and we spoke about density curves and distributions, and in particular, the normal distribution. And we did some examples of the normal distribution. I believe the last thing we did was we talked about z-scores, correct? And we did example of that 70-inch, not abnormally tall woman, and how to determine whether or not any data point is abnormal by comparing it to, or by calculating the z-score. So let me now, well, again, were there any questions on any of that, the stuff that we did last time, or was it all very, very straight? And flower, I wasn't able to finish. Did anyone have any issues with the quiz in terms of it letting you submit things and pick multiple choice answers and things of that nature? Did anyone have any issues? Oh, interesting. Well, why don't you speak to me right after class? We can discuss it. But right now, I'd like to move forward. Okay. Okay, so we're going to start now with section 3.6. on finding normal proportions. 3.6 on finding normal proportions. And we're going to do it in a few different ways. But essentially, historically, there are three different aspects of the normal situation. There is the raw data. These are your actual values that you get for your experiment or for whatever the situation is. There are your z-scores. And there are your probabilities. Historically, in order to get to your probabilities from the raw data, you have to go through z-scores. Now with technology, both your calculator and your computer, various technological programs and whatnot, you can go directly from raw data to probabilities. So this is via calculator or a computer. If you want to go, if you don't have those and you have to go from z-scores, you would do that route, and this one uses tables. This guy uses the formula z equals x minus mu over sigma. And for this one, we look up what's called a z table, which is actually literally in the back of the book. You'll see it. Let's see if they have one here. Now with computers and calculators, they don't always need one. But let's see. Yeah, the book has one. If you have the book, you will see it on pages 680 to 681. You will see a standard normal table. So we're going to use a few different techniques today. We're going to do it by hand. We're going to do it by tables. We're going to use our calculator, and we're going to use a computer program. We're going to use Crunchit, which we have on our, well, normally I would use Crunchit, but if the website is down, I might not be able to do that today. But at least we have our calculator. So we're going to do a bunch of examples to illustrate these various techniques. So we'll start with this example. and if you have the book, it's on page 85. It says, there's a lot of words in the beginning, but it essentially says that we need on the SAT, so need a 980 on the SAT. That's actually the 1, 2, 3, 4, that's the seventh line of the problem. So there's 6 lines of words, which don't really matter when it comes to the actual math, but helps you see the context of the problem. But at the end of the day, we need a 980. And SATs are normal. And I'm going to use a certain notation here, which we see often. N, comma, 1059, comma, 210 squared. So this notation here. Okay, every one of those symbols means something. What do you think the capital N tells you?
If it's a normal distribution.
That it's normal. What do you think the 1059 tells us? Remember, for a normal, we need two not. Yeah.
Sorry, could it be the standard deviation?
Not the standard deviation, but rather the
Mean?
mean. No. Z-score, again. Z-scores are what you get when you transfer your data from your raw score using the formula here that computes the Z-score for your data. This line is talking about SATs in general. There's no actual data that we have in front of us. This is telling us that SATs have a distribution that is normal. The mean is 1059. And what's the other number that we need to determine the mean, to determine which normal we're talking about? What's the second of the 2 numbers necessary to know what normal we're talking about?
Standard deviation.
Standard deviation. So it's not the 210 squared that's the standard deviation. It's just the 210. The 210 squared, that's what we call the variance. And if you recall back on the first day, maybe the second day, when we were talking about the formula to calculate the standard deviation, we actually first found the variance, and then we took the square root of that to get the standard deviation. So 210 squared is the variance. The square root of that is 210, which is the standard deviation. So we need a 980 or better on the SAT. And the SAT is normal with a mean of 1059 and a standard deviation of 210. So the question is, what is the probability a randomly chosen person scored above a 980? This is the question that we're looking for. What is the probability a randomly chosen person scored above a 980? So when I do these types of problems, even though I don't need this technically for my answer, I like to imagine a normal curve. I like to draw one. Where is the mean of a normal curve?
In the middle.
In the middle. And what is the value of the mean in this particular example? 1059, good, 1059. Where is our data point?
$980.
980, which is where in relation to 1059?
To the left.
To the left. Let's try to figure out and get at least an approximation of where. If I go one deviation to the left, one standard deviation to the left, first of all, how far have I gone? And two, where am I physically? Like if you were to point on this curve to where you are, if you are one standard deviation to the left, approximately where are you located? Where is one standard deviation to the left?
849.
Mathematically, it's 849 because it's 210 less than 1059. That's half of what we were after. But physically, where are we located? Is it over here? Is it over here? Over here? Over here? Where exactly would I locate 849? Where would it be on my picture? I believe we did this last time. Anyone recall?
Isn't it when it starts turning into a bowl shape? Wouldn't it be like the point of something?
Yes, yes, from the bowl to the, it's called the point of inflection, yes. It's where it transitions from being like a hill to like a bowl, somewhere around there, give or take. Does it sound like a reasonable amount? So this
Yeah.
right here, this is 849. So where is 980?
Somewhere in between.
Somewhere in between. Halfway in between would be like 954. So maybe just past, maybe like over there. Does that seem like a nice approximation for where I am?
Yes.
And what am I looking for here? The probability that a randomly chosen person scored above a 980. So which portion of the graph am I interested in?
The right side.
I'm sorry?
The right side
The right side of what?
of 980.
The right side of 980. So I'm essentially interested in the probability of landing past 980. So I want the area all the way out to infinity. That's what I'm looking for. Now, as a quick lower bounds, if I had to give a number smaller than my answer, what is an obvious number smaller than my answer?
50%?
50%. Because if all I focus on is on the left side of the curve, that's 50%, correct? That's half the curve. That's half the graph. And I'm more than that. I'm a little to the left of that. So as a lower bound, it's certainly more than 50%. So if I get something in the vicinity of like 60, 65%, I'd probably trust my answer. But if I got off my calculator 22%, I would say, wait, either I'm not understanding the problem or I did something wrong. Right? Makes reasonable what I'm saying? Okay, so let's do this in a few different ways. The first way we're going to do it is going to be to calculate our z-score of our data point. What is the z-score for 980? What is the z-score for 980? To, let's say, 3 decimal places. The formula for the z-score, I just wrote down, we saw it before. The formula for the z-score is x minus mu over sigma. Data point minus mean divided by standard deviation. So what do I get for my z-score?
Would it be wrong if it's a negative?
It's negative because it's to the left of your mean, which means you are beneath your mean. Z-score, one second, z-scores tell you how far above or beneath your mean you are. So positives will be to the right, negatives will be to the left.
Okay.
So I get negative 0.338,
3.8.
which I saw in chat, but let's go to 2 decimals or 3 decimals. So it's approximately negative 0.376. And this is what I mean, by the way, up here above, that raw data and z-scores are connected via the z-score formula. You can go from one to the other if you know either one. In this case, I can go from raw scores, raw data to my z-score. So I have negative 0.376. Does that make sense? Yes, no?
Yes.
Sorry, do you mind explaining your answer?
Yeah, I'm sorry. So which part? How I got that
Just
number?
for the z-score.
Well, what's the formula for z-scores? What's the z-score formula?
I have x minus, is that the mean,
Yeah,
over standard deviation?
okay, so what's the x in this case?
It would be 980,
And what's the mean?
right? 1059.
And
Okay,
what's,
I got it. Thank you.
okay. Okay, so now, oh, I can't load up. Is it working yet, by the way, or still not? Macmillan, anyone having,
Mine's working.
okay, oh, here it is, good, excellent. Okay, so it's open now. Remind me to go over the quiz near the end. But for now, since I already started, I want to jump into this. I want to go to the tables in the back of the book. All right, I'm going to share my screen here. Okay, so here we have, and if you have the book, you can look in the book, but here we have here we have what's called a standard normal cumulative proportions table. What it does is it gives you the probability. And if you look at this graph here, if you give me any particular value, it gives you the probability of being to the left of that value. In our example that we're working on in the book, we want to the right of that value. How is the number to the left and the number to the right related? If I look at the likelihood of being to the left and I look at the likelihood of being to the right and I add them, what do I have to get?
100.
I have to get 100%. I have to get 1 because it's one or the other. So if the table gives me to the left, 1 minus that gives me to the right. So let's find the value. What I'm going to do is I'm going to look for my z-score. Now, the z-score, I'm going to use this column here and the heading. This column here gives me the number before the decimal and the first decimal place. This column here gives me the second decimal place. What was my z-score again?
Negative 0.376.
Okay, so with this table, negative 0.38 is a little better because it only has 2 decimals to work with. So I'm going to scroll down to negative 0.3. Negative 0.3, and the headings are 8 is the second to the last column. So negative 0.38 would be the second to last column, would be right here. 0.3520. That means the likelihood of being to the left of negative 0.38 is equal to 0.3520. Since we want the likelihood of being to the right of that number, what would I do?
Subtract it.
1 minus,
Say again? What would I do? I didn't hear it. What would I do?
subtract it from 1.
Subtract it from 1. So what is 1 minus 0.3520?
Point 648.
0.6480 or 0.648. Does that seem ballpark what I expected? Sure. Of course, it's only ballpark. Even 0.648 is only an approximation because it wasn't negative 0.38. It was negative 0.3761904762. And unfortunately, my calculator or my table can't be that accurate. So this is what we get from a table. Let's now do it with our calculator. So I'm gonna pin my screen, so hopefully you all see this. Okay. So here's my calculator. I'm gonna hit seconds, DISTR, distribution. And what am I gonna look for here? Which one?
Statistics. I think.
Well, I mean, I already have a list here. Which one on the list is the one I want to use?
Oh, after that.
The first one?
So it's actually not the first one, but that's a good guess that I would use the first one. It's actually the second one. I don't want to use the normal PDF. I want to use a normal CDF. Because remember what that table was titled as. Did anyone write down the title for that table that I just showed you? It was a standard normal, but there was an extra word in there. Anyone recall what it was?
Culminated.
It was
Like that.
cumulative proportions. Because we're adding everything up until that point. We're accumulating everything up until that point. So the CDF is actually what we want to work with here. So I'm going to go down, go to number 2 and hit enter. And I have normal CDF. And it says, okay, give me the lower, give me the upper, give me the mu, give me sigma. In our example, what should our lower be? What should our lower be in our example? Where's the start of our area that we're after?
980.
980. So for my lower, I'm going to put in 980. Upper, what do I want to put in?
1059.
Well, that's not the upper. I don't end at 1059. In fact, wait, in fact, 1 second. In fact, which of these would I do for 1059?
Oh,
The-
so
Mu, the mean. So the next row,
I have a question.
I can get
When
there.
when I do the number 2 and then enter, it just goes like that.
So you have a different calculator than I do. So if
This
you
doesn't work yet.
have an 83, this is an 84.
So how would I do it on here?
I'll show you in a second.
Oh, okay.
Give me a second. So I put in the lower 980. I skipped the upper for a minute. I put in the mu was 1059. What do I put in for sigma?
210.
210.
210. Okay, so I just put in sigma 210. The question is, what do I put in for the upper?
Is it infinity?
So I would love to put in infinity, but unfortunately, infinity is not a number. So how can I tell my computer to put in infinity? I just do the following. I hit 9 a bunch of times. I just tell it to put in a very large number. Because remember, the normal curve dies down very quick, right? By the time 3 sigmas, we already have 99.7%. So that's just a really big number. And then I go down and I hit enter at paste. Now, when I do that, Leanne, this is what I see. Which means on your calculator, that's the order of the numbers that you want to put in. Lower, upper, mean, sigma. You got to do it manually. With us, we have that little thing. And let's see, when we hit enter, what do we get? Seems fairly close to what we got from the table, correct? Just a little more accurate. A little more accurate.
That table, can we find it on the back of the textbook?
The table's in the back of the textbook. You can also do a Google search for a standard normal table, and it will give you one as well. Of course, having a calculator do it for you is a lot better than looking it up yourself, right? So from calculator, we got 0.6466 approximately, which is slightly better than what we got from the table. Do you agree? It's a little more accurate. And then the third way of doing it would be to use Crunch It. Uh-oh. How do I find Crunch It here? I got to go into an assignment, right?
Yeah.
I think we did this one time before. So I believe it was question 4 we went into. Yeah, so here we go, Crunch It. All right. So I don't need any of these things. I can delete all this stuff. I don't need any of this. But what I am going to do is I'm going to go to distribution calculator and go down to normal. Put in a mean of 1059. Putting a standard deviation of 210. And do I want the probability that X is less than or equal to something or greater than or equal to something? In our example, do I want less than some number or greater than some number?
Greater.
Greater than?
Greater than.
Greater.
Specifically greater than what?
980.
980. And then I hit calculate. I hit less than by accident. I didn't switch it. Greater than. Calculate. And what do we get? Not only do we get the answer that we got from the calculator with a lot more decimals, by the way, but we also get a lovely looking graph, which tells you exactly what you shaded in. Does that make sense? So we have the Crunch It approach, which is essentially a fancy calculator approach, and we have the table approach. Now you might say, well, wait a second. What if I get stranded on a desert island and I don't have my book and I don't have my calculator and I can't do it with any of these things? What do I do then? Well, unfortunately, in that case, you're shit out of luck because there's really no other way of doing it. Okay, so you're either going to use your calculator or you're going to use your computer or you're going to use a table, but this is not something that we do by hand. Questions on that so far? All good? Okay. So let's do another one.
What?
Yes, question?
No.
All good? Yes, no, maybe so? All right, let's do another one. Ready? Here's another example. This is also this is an exam called an ERW exam, evidence-based reading and writing test. And we're told that it follows an approximately normal distribution. And it says 531. And then it says 104, but the book's notation is a little bit different. So I want to basically not correct, because what I did wasn't wrong. It's just not what the book does. The book doesn't do the whole variance thing. So please go back and fix that. The book just gives the second number as the standard deviation. And because the book does that, I want to make sure that we do exactly the same thing that the book does, so that we don't get two different answers. But in the literature outside, you will see both notations. So please be aware of that. So please go back to the last example. It doesn't change any of the math that we did. It just changes the notation. And in our example, just be aware that this 104 is in fact what? What is the 104?
Standard deviation.
It's the standard deviation. And what is the 531?
The mean.
The mean. And the question says as follows: how high must you score so that you fall in the top 10%? How high must you score so that you fall in the top 10%? And what you'll notice here, in comparison to the previous problem, it's essentially the exact opposite. Because in the last example, you had your data and you computed the likelihood of being to the right. You went from data to probability to proportion. Now we want to go backwards. We want to go from proportion to data. We want to calculate the actual point that you must fall on to land in the top 10%. So the first thing I'm going to do, just to visualize, is make a normal curve that represents the situation. You don't have to. I can do all the math without it. But again, it helps me visualize what's going on. So there's my normal curve. Where's the mean?
The middle.
The middle. What is the mean in our example?
531.
531. And if I asked you to shade the top 10%, I'm not Sean Connery, so it's not percent, it's percent. If I asked you to shade the top 10%, where would I shade?
Somewhere in the left.
Somewhere on the left. Is that the top 10%? Where's the top 10%?
On the right.
On the right. How far from the right would I shade? Start here. How far should I get? Do I get, all the way over here? Does that seem reasonable? Where does 10% end? What approximately would you say is roughly 10%?
Somewhere in between the first and second standard deviation.
Somewhere in between the first and second is correct. So if the first deviation is here and the second deviation is here, then we're certainly shading here. And how much more would you say approximately?
Just a little bit to the left of the second.
Okay,
Yeah,
something like there maybe? Approximately, ballpark? Okay. So the question is, what is this? That's the goal of the question. What is this? Right, what number is that? That's the score that we need to know where you have to score to fall in the top 10%. So we're gonna do this in 3 ways. I'm gonna do it via the table, via the calculator, and via crunching. So let's do it via the table first, since it's the most inaccurate. So let me share my screen again. And where, no. Do I got to do it again from scratch? I guess so. Okay, so let's go back. That's annoying. Okay. Okay, so we're back to our standard normal table. First thing I realize is that the table, again, gives me likelihoods of being to the left. And in this particular problem, I want the likelihood of being to the right. Now, what percent do I want to the right again for our problem?
10%.
10%, which means what percent would that be to the left?
10.
Sorry?
90.
90%, right? 90%. So in the table, I'm not looking for 10%, I'm looking for 90%. But remember, I'm not looking for the z-score. I'm looking for a probability of 90%. So I will find that in the actual table. Now, this graph are all the negative z-scores. These are all to the left. So I want something around here somewhere. So let's go probably to the next page. Okay, here we go. And now let's find a probability of 90%. Anyone see a probability of 90%?
There's a 0.9015.
There's a 0.9015 and there's a 0.8997, and it should fall somewhere in between these two, right? Closer to which one?
The 8997.
Closer to the 0.8997. It's only 0.0003 away versus 0.0015 away. So it'll be closer to this one. Now this one has a z-score of what? What's a z-score of 0.8997?
1.2.
1.28.
1.28, right? And this one has a z-score of what?
1.29.
1.29. So if I had to guess, I'd pick 1.281, maybe 1.282. Does that seem reasonable? It's somewhere in between, but closer to this one. Let's do 1.282. So I'm going to pick as my z-score 1.282. So this is z equals 1.282. That's what the table gives me for my z-score. But that's not the score that I need to pass in the top 10%. Obviously not. The mean is 531. If you score a 1.282, you're not scoring very well. So what do we have right now? We have the z-score, but we don't actually have my data. How can I go from knowing the z-score to figuring out my data?
You just rearrange the formula.
Just rearrange the formula. Which formula again? I forgot. What was the formula?
Z-score formula.
What is the z-score formula, please?
Z equals the x minus mean over standard deviation.
So if I want to rearrange this to solve for the raw data, what would I get? Purely algebraically, we're not plugging in numbers yet. If I were to rearrange this to solve for x, what would the formula give me? X equals what?
Would it be, you like multiply the standard deviation and then add it to this, so then you use the standard deviation times z in the x. I don't know.
No, don't stop. You're on the right track. Come on, keep going.
So yeah, you cancel out the standard deviation on the other side, and then you add it to the z. And then you add the mean on one side.
Yes. So it's the mean plus the product of sigma and z. Right? You multiply both sides by sigma. And then you add the mean. So in our case, what is our data? What is our point going to be?
Be 531 plus 104 times 1.282.
Assuming that's correct, because I was yawning and I didn't hear anything you said. What did you get as your answer?
Oh, I didn't solve it yet. I was just.
Oh, so go ahead and do that, please. So I can determine if what you said was correct. Or anyone else.
664.32.
664.3, what's that? 0.328. That, no, I do get 0.328, but to get a precision like 0.328, remember, we were only guessing at 1.282. We only really have 4 significant figures there. So 664.3 would probably be best. Sorry, I know this isn't a science class. I don't want to bring in significant figures for those of you who have, nightmares of chemistry or physics. But because I teach both chemistry and physics, I don't mind so much. So the table approach gave us 664.3. Does that seem like a realistic value given what we expect with the normal curve? Doesn't seem half bad, right? So let's do it now on your calculator. Okay, so on the calculator, we are again going to do second distribution. But this time, we are not going to do normal CDF. We already know what normal CDF does. Normal CDF says, oh, lower, upper, mean, sigma. Here's my probability. That doesn't say, oh, here's your probability. That's my z-score. It doesn't go in the opposite direction. So which of these do you think would go in the opposite direction?
1.
Not 1.
Is it 3?
Number 3, the inverse normal. What does inverse mean? Basically, reverse the direction. Now, my calculator, which is certainly better than the TI-83, Leanne, I'm just saying, my calculator says, what area would you like? What mean would you like? What sigma do you want? And not only that, do you want the area on the left, in the middle, or on the right? So in our case, we're going to do an area of 0.1. We want 10%. What's the mean in our example?
530.
531. What is the sigma in our example?
104.
104. Do we want that 10% to be on the left of the graph, the center of the graph, or the right of the graph?
The right.
The right, so I move to the right and enter, and then I will do it like this. And I have inverse norm, area, mean, sigma, right. Leanne, you want to try that? See if that works on yours?
Yeah, but it doesn't give me an option to put right, left.
Right. So as far as I know, yours only does left. Which means you won't use 0.1, but rather you'll use if it's not
90, 0.90.
0.90. Because if it's 0.1 to the right, it's also 0.9 to the left. It's the same thing. And then when I do it, I hit enter. What do I get? $664.581365.9, if I'm reading it upside down correctly. Did I say that correct?
Says 629.
629. Sorry, I'm looking at the numbers backwards.
Okay,
So, do you guys see it the way how do you see it, by the way? Do you see
We see it the right way.
you see it the right way?
Yeah.
So weird. I'm seeing it the wrong way. Wonder if I can see myself on this screen. Hold on. Ah, there it is. 664.281369. Yeah, okay. Which, huh?
I don't see mine that says right, left, or center.
What calculator do you have?
The TI 84 plus. Do you want me to show you?
Yeah, I'm gonna unpin mine.
Do you see it?
I have glare.
Let me turn this on.
Tilt it down more. That makes-
Yeah,
It only says area, the mean, the standard deviation, and paste.
so then yours probably also only does left, which means you'll need to do 0.9 as well.
Okay.
Because if it's 10% to the right, then it would be 90% to the left. Does that make sense?
Point
Okay,
9 on area.
I'm sorry?
You said to put 0.9 on area.
Yes, because if we want 10% to the right, it's the same thing as wanting 90% to the left. So calculate, so this is from table, all right, this is from table. And calculator, oh, I'm not sharing my screen, hold on. And calculator gives 664.3 as well. So that was a pretty good approximation, wasn't it? More decimals here, but to 4 decimals, it gives the exact same value. Did you get that, Flower?
Yes, I did.
Okay. So now, approach number 3. Let's use crunch it. So crunch it. So again, on crunch it, we're going to go to distribution calculator and we're going to use normal. So what change are we going to make here, do you think? Obviously, we want a different mean. What mean do we want?
531.
531. And we obviously want a different sigma. What standard deviation do we want?
104.
104. But this is telling us to put in our raw data and pick greater than or less than. And we don't want to do that because we don't have that, right? We don't have the raw data. We're looking for the raw data. So what do you think I can do? What do you think I should do? Look at the screen.
Maybe try that other tab.
Maybe try that other tab. That's a great idea. Try that other tab, quantile. What quantile do I want here? Well, this probably, well, obviously see when we look at the graph, but this is probably the same thing as your calculator asking for area to the left. So what number should I put in?
10%.
That would be to the right,
0.9.
0.9. Let's calculate and see. Yeah, there it is. So just like your calculator, the 90th quantile, the point at which 90% is to the left. And by the way, you probably heard that terms, especially if you have, children and you take it to the pediatrician to see how tall they are, what their weight is. Oh, my child's in the 70th percentile. Percentile and quantile are saying the same thing. They're synonyms. So we see here 664.28136218166384 would be your raw data. Would it be your raw data? So crunch it does not get your z-score. Your calculator does not get your z-score. Only the table gets the z-score, which you then need to get your raw data. These guys go directly to your raw data. Does that make sense? Yes?
Yes.
Yes and yes. Okay. So that takes us to the end of chapter 3, which means you should be ready to do the chapter 3 homework. I am going to stop sharing my screen here and let's take a look at the website to see when the due date is for the chapter 3 homework. Okay, my course. So the chapter 3 homework, which is up, is due September 23rd, which is a week from today. The chapter 2 homework and the practice quiz are both due in 4 days. Should have been due today, but I didn't change it fast enough, so you guys got a break there. And I don't have to open the chapter 4 homework yet. But the question was the mini quiz, which not everyone took. I just saw that. Hold on. Let me go back for a second. 35 of 43 people did the mini quiz. 35 of 43. Why didn't everyone do the mini quiz? Who's not here today? That's weird. We only have 1, 2, 3, 4 or 5 people missing. So that means some of you here didn't do it. I don't know why. Mini quizzes are worth part of your grade. Do the mini quizzes. But anyways, let's go over it. There were 11 questions. Share my screen. All right. So which one do you want me to go over? All of them or specific ones?
Can you go over number 3?
Other questions, chapter, this one right here? I think people might have gotten different versions of it.
It's about the median age of 5 people in a meeting.
The age of,
Nice.
do you remember what, was it a white histogram or a gray histogram?
It didn't have a histogram. It was just writing.
Well, they could be mixed up then. They could be mixed up, but all of them seem to have, well, okay, let's, hold on.
They get mixed up every time you Go
Yeah.
back to the quiz.
Oh,
So that's gonna cause difficulties with going over it. Okay. All right, well, let's go through them. I'll just pick one from each one. So stemp plots. Stemp plots. Okay, that's funny. The stemp plot below displays midterm exam scores for 34 students taking a calculus course. The highest possible test score was 100. The teacher declared that an exam grade of 65 or higher was good enough for a grade of C or better. So the stem plot is most similar to a box plot. Well, certainly not. They look nothing alike. A time plot doesn't even make sense. Reporting the 5-number summary for the data, that's just a list of 5 numbers. But a histogram with class intervals 30 to 40, 40 to 50, and so on, that's exactly what a stem plot is, right? The first row is the 30 to 40 row. The second row, 40 to 50, and so on. That makes sense, right? That shouldn't have been a big surprise. No questions there, right? Hopefully. Yes, I need input. I need something to say, someone to say something. I don't know, but I just keep going on otherwise. Yes, okay. Question 2, histogram. I'll just look at this one. A survey of radio stations was conducted following the attacks on the World Trade Center in 2001. That's quite auspicious timing. The station rankings were included in the survey. The histogram below has the interval limits 0 to 50, 50 to 100, 100 to 150, and so on. Okay, a plot of the histogram above shows that the approximate number of rankings between 50 and 100 is, it looks like about 60. So at least 50, but less than 65 is certainly the correct choice. I mean, I would say it's just straight up 60, but it certainly is between 50 and 65. So that one was,
I think
yeah.
it might be like different because the one I took didn't have the last question you just did or this question.
Mine either.
Yeah, mine either.
Well, I know because the first one had 4 options. I only looked at one of them.
Oh, okay.
The second one had 5 options. I only looked at one of them. Right? So some questions are going to have multiple options. So you might not get the exact same question, but it should be ballpark. Does that make sense?
Yeah.
Okay. So that was question 3, and it says 1 to 2 here. See, yeah. 2 of these 4 were given. So the next one, the stem plot below displays midterm exam scores for 34 students taking a calculus course. The highest, okay, the same thing. The percent of students earning a grade of C or higher. Well, a C is 65 or higher, correct? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, divided by 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, divided by 34. That gives me, on my calculator, 64.7%, which is about 65%. Yes? Okay. The third one, sample of 40 employees from the local Honda plant where I was obtained, the length of 10 months, okay. In the stem plot, 5/2 represents 52 months. What will be a better way to represent this data set? Well, look at these stems. Look at these rows. I mean, they're huge. So split them. Right? We talked about that in class. Split stems when they're big can clear up confusion. And the last one for number 1, less than 5 years. 5 years is 60 months. 60 months, less than 60 months does not include these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10, 20, 30, 1, 2, 3, 4, 5, 6, 7, 8, divided by 40, that's 25%. So that was, yeah, okay. Anyways, question 4, it says 2 of these 12 2 of these 12. So there's a lot of them here. 1 of the 5, 1 of the 7, 1 of the 5, 1 of the 3, 1 of the 3. Yeah, so it's going to be really tough to hit whatever question you had.
Could
Yeah.
you, for number 8,
IQR?
yeah, well, my number 8 was, it was asking if it's like quantitative or categorical, and it was the only one I got wrong, so.
Okay, well, it's not that one. It's not that one. Of course, your 8, it might be mixed. So it might not be quantitative or categorical. What would be, let's see what these are. It's probably in this category, I would guess.
You
So-
want me to just read my problem from my screen to you?
Specifically yours, but if I load up yours, everyone sees your grades.
No, I mean, like, I just read you the problem because I have it open.
Oh, well, how about, yeah, why don't you share them?
Oh, share my screen?
Yeah, share your screen.
Okay. So
Okay, what's the difference between a histogram and a bar chart? So remember, a histogram is used for,
not this question, this one, sorry.
okay. Employees at a large company are surveyed about their health insurance status. Em- Employees are coded as 1 if health insurance is obtained through the company's benefit program. 2 if health insurance is obtained from another source. Or 0 if the employee does not have health insurance. This variable is. So we never used the term quantitatively categorical. That was never a term that we used in the class ever.
Well, it just made sense because,
I know. But we never had that term, did we? I can see why it would make sense because you're using numbers to describe categories,
yeah,
but we never use that term. So this is categorical.
even if it has numbers in it.
Oh yeah, we spoke about that. Zip codes have numbers in it, but you can't average them. It doesn't make any sense. They're just categories.
Okay,
So yeah, so even with numbers, it's strictly categorical.
okay, thank you.
Okay, if anyone else wants to share a specific question from theirs, as opposed to me randomly guessing, you're more than welcome to. Anyone else want to share a question that has a question?
Yeah, can I share the one I asked about earlier?
Yeah, please go ahead. Okay. The median age of 5 people in a meeting is 30 years. So there's 5, that's an odd number. That means the third one on the list is 30. Do you agree?
Yeah.
Then one of the people whose age is 50 leaves the room, which is a bigger number. So one of the 2 bigger ones leaves, which means now we have 4 data points. So the median is no longer the same third one. It's now the average of the second and the third, which means it has to go, it's either the same if they were both 30, or it goes down.
Which is what I was thinking.
So the median age of the remaining 4 people in the room is not able to be determined from the information given, because both 30 and 25 are possibilities. What if the second one was 20 and 20 and 30 averages to 25? What if the second one was 30 and then 30 and 30 averages to 30? There's just not enough information.
Okay.
Does that make sense?
Yeah. I didn't think about that though.
But it makes sense now that you see the answer though, correct?
Yeah. Thank you.
You're welcome. Does anyone else have any questions that they want to go over? Other than possibly 1 or 2 questions, was the quiz fair? Was it representative of what we went over in class? No surprise. I mean, yes, I'm not saying every question was exactly the same as something that you've seen before. You know, that particular one, for example, we never specifically went over, but it was representative of what we covered, right? And you're going to find that the exams in general they're representative of what we cover. It shouldn't be any surprises. I mean, yes, some of them might be a little more challenging than others, and some questions are from the homework. That's true. You know, it's the same question bank, so you might very well just see the same questions a second time. That's certainly a possibility.
I have a question.
Yeah.
Not this case, but for the final exam, is it going to be, I know it's in person, but it's going to be online, or we're going to have to pay for it?
No, I'm pretty sure it's gonna be by hands because I don't think we have the computer resources to have everyone taking them via computer at the same time.
Okay.
Because I mean, Math 140 has, you know, probably 1,000 students amongst all the Math 140 sections, all taking it at the same time. So chances are, I would be flabbergasted if it wasn't by hand. Okay. All right, so we finished chapter 3 today, and next week we will move on to chapters 4 and 5. Best fit lines, if you've seen them before in some of your science classes, and various applications thereof. So we're going to end a little early. I want to rest my voice a little bit, my throat. Hope you understand. I've been teaching for the last 9 hours straight. So I will see everyone on Tuesday. Have a great weekend. You too. Yeah, if you want to stay and ask a question, stick around. I'm more than happy. My office hours are coming, so I'm more than happy to to answer any question.
Thank you, Professor.
Welcome. You're welcome.
Thank you.
You're
Thank
welcome.
you. Have a good
I
day
just have a
or evening.
couple questions.
Yes, go ahead.
For our calculators, we don't have to have the T84, right? But you just recommend it.
I mean, it's the one that I'm going to demonstrate things with. If you have a different one, I won't necessarily know how to do things. So you'll be on your own in terms of.
Okay. Okay, well, I have a Casio and I've used it for my other stat class. So
Yeah.
in high school, so
Yeah, I can't.
and,
Yeah, just to interject, a Casio is popular enough that if you go on YouTube and say, "Hey, how do I do this?" Somebody will have made a video explaining it. Because I was helping someone yesterday, one of my students in Puerto Rico, who had a calculator that I had never heard of. And we were trying to convert it from radians to degrees. And I'm like, I don't know. Let me check on YouTube. And nobody's ever done it because I couldn't find anything on it. So as long as it's popular enough, you should be fine.
I have a question about the calculator.
Yeah,
Oh,
one second. One second. She had a second question. Go ahead. Yeah, I have a TI 84 plus.
it's just for the homework, how are you grading it? Is it based on completion or like our attempts?
I don't go through it. The computer does everything. So I assume it's based on accuracy. Not just, hey, I tried it, I should get full credit. I would be very surprised otherwise because the computer can see, hey, that's right or wrong. It might take off points for every incorrect attempt. I don't know. I've never really gone through it, but certainly it's based upon accuracy.
Okay.
Okay.
That's it. Thank you.
You're welcome. Was there another question there?
Yeah, I had a question on the homework for chapter 2. Like I was getting this one answer wrong, but I don't necessarily know why.
Okay, one
It was
second.
fruit punch.
Yeah, 1 second, Leah, I got you. You're good. Okay, so which one? You want to share your screen?
Yeah.
Okay.
So this is the one. So I got the second part right, which is fine, but then it's this part where it's just asking for the minimum.
Yeah, so go up and see the questions. So student engineers learn that although handbooks give the strength of engineers, variation everywhere. Okay, so the table contains the data from a typical student return. Okay, fine. Let's use Crunch It.
Yeah. And
Okay.
then,
So
Wait,
just
I did that problem. I actually know what the problem is because I kept getting it wrong. It says
Yeah, me
it's your
too.
decimal place. It says thousands, so you put like it's 23, and then you put like the decimal point right there.
oh, 23 right here.
Yeah,
Yeah,
23.
I think
it
it's
won't
good.
let you do the
No,
commas.
yeah, it's 23.04.
Oh, I see.
Wait, what
So
happened?
instead of the comma, you do the decimal. Because it won't let you do the comma for the thousands.
Oh, so your answer is in thousands. So it's, wait, go back up. The answer to the first one was 23,040, correct?
Or yeah, this is my attempt one.
No, I know, but I'm saying, forget about your attempts. The answer to the first question is 23,040, correct?
Yeah.
So how many thousands is that? That is 23.04 thousands.
Got it.
And they want 2 decimal places. So 23.04.
Okay, cool.
Okay, does that make sense?
Yeah, that makes
And
sense.
that's what they were saying. I wasn't trying to override you guys. You guys had it. I just,
Yeah.
Okay, I'm sorry about that. I didn't mean to
That's just annoying.
jump over anyone there. Yes, it's annoying following directions. I know. It's so tough actually reading what they asked for and then doing it. So that's crazy tough.
Just do it in the same data as it is in the table.
Well, I hear you. That's true. That's true. All right. Any other questions? All these people who pretend to be here but are not really here.
I sent you a email about the quiz.
Okay. Oh yeah. So you tried again. Let me take a look if I have it. Okay. Hold on.
Your email, like when I click on it, it redirects you to someone else.
That might be why I didn't get it.
Yeah, it's really weird, but
Okay, but I have it now.
yes.
The website froze and only let me answer one question. Is it possible for me to get a reattempt?
Yeah, I also had the same issue about the mini quiz. I tried sending you an email, but I don't think it went through.
Okay, so
I had the same problem, but I didn't send you an email. I was gonna wait to talk to you about it right now.
hold on a second. Let me see what I can do here. Hold on. So let's see if I can find a way to okay, give me a second here. Edit resource details. Create student exception. Okay. Okay, so exception number 1. So Roberto Flores, you want exception number 1. Who else wanted exception number 1? Or an exception?
Me and Flower.
Yeah.
Who's me? I don't know me. Who's me?
It's Sana and Flower.
Okay.
Me as well, Estrella.
Sorry?
Estrella.
Estrella. Okay, so I have Roberto, Sana, Flor, and Estrella. Is that correct?
Yes.
Okay, so I'm gonna make the due dates. Today is the 16th. I'm gonna give you, would till midnight tonight be enough time?
Yes.
Yes.
Okay, so due dates visible from now until September 16th. Oh, that's November. I don't want November. That's crazy. September. Oh, okay, wait. That's fine. November 14. Okay. Okay, so okay, so I'm going to do save student exceptions. Okay, do you guys see it pop up there as I'm going to stop recording it.